So 第53页。Okay, now page 53. Now let's talk about let me explain some words. Centroid is this one, and center of gravity is this one. I think you have learned center of gravity in your high school physics. Now, and the difference between the two is like this. Centroid, we are talking about geometry. And for center of gravity, we are talking about force, or sorry, or mass. And there is a small difference between these two words. Centroid is talking about geometry, the center of something according to geometry. And for center of gravity, we are talking about center of something. We are talking about mass or force. Okay. Now we are. So let me go through all the words I want to cover, and then I will go to the mathematics. Now, this one is I think I typed this here, so you can read this. Okay. Now, and so let me have two examples here. The left one is you can see in Hong Kong and in London, and this is called double-decker bus, and I think in Taipei we have this as well, and for this kind of buses, and so if we go down like this, it is of course we know the Chinese, and but in the English we would say the bus topples. And for the what's the thing on the right? Where will you see it on the? Where will you see it? It is and ejector seat. Right. Now I think which one should we talk about first? Okay, to the left. So, and for a double-decker bus, the laws in Hong Kong and London says that this platform this platform should go to 28 degrees, and the bus will not topple and or remain stable. And at the same time, if it at the same time it is not empty, and it has masses here, and weight of passengers. Here, and so it is not easy to design the double-decker bus, because that when it is under test, and we put weight of passengers here, and then we turn it by 28 degrees, and it remains stable. So, and actually, for this kind of buses, and it usually have the base or chassis is made of steel, and its bodywork is made of aluminum. It's okay. So let me talk about all the words here. So it has to go through 28 degrees, but it's still stable. And at the same time, that the weight of passengers and are put here, and it needs to be stable. It cannot topple at this angle. Okay. So usually buses are designed with steel chassis, and you can use this word for cars as well. All cars, that the base of any car is called a chassis, and the body is made of aluminum. Okay, usually it's like this. Now, any problem with this? If not, then we go to the right one, the one on the right, ejector seat, and you can see it on fighter jets, right? Now, and so we have ejector seats on the fighter jets, and now let's think about this. And of course, you can see there are rockets and going this way, and then the person go this way, right? Now, if we have so let's say we have so if we have action of the rockets here, and then we have the reaction to the person here, and then it will go up, right? So let's think about it. For example, the center of gravity of a person is, say, maybe here. I would say this one is called C dot G dot center of gravity. You have the center of gravity of the pilot there. Suppose we have these two rockets, and having the force pushing to the chair is like this. What will happen? And from we have a force couple system. If we have force going here, it means a force here and a couple here, right? So the pilot would go round and round and round, and so it is not very good, right? So it will have moments here. Okay, so for these ejector seats, and they need the biggest thing they need to do is to make sure the force is going in this direction. It's okay.